the foundational column, so you should take the fundamentals courses in the order shown. Likewise, you build your knowledge as you progress up the intermediate column. The foundational courses are prerequisites for the intermediate courses. The courses are color-coded to enable you to identify the relationships. For example, the ontap NAS fundamentals, ontap NFS administration, and ontap SMD administration focused on NAS. The location marker indicates the course that you're attending. To prepare for this course, you should have taken the ontap cluster fundamentals course. You should complete this course before you attend the ontap SAN administration course. The ontap SAN fundamentals course is written for SAN administrators. It's an introduction to the concept of block-level access using SAN protocols. In this course, you learn how ontap provides block access to a host by using SAN protocols. You learn about runs and how to map them to a host to enable read and write access. You also learn about multi-pathing techniques that can improve availability and performance. Module 1 discusses block access. Operating systems and applications request data at either the file level or the block level. Network-attached storage, or NAS, provides file-level access to data on a storage system. Data is accessible from a network that uses ontap services. Such services include a common Internet File System, or SIFS, which is a dialect of Server Message Block, or SMB, and the Network File System, or NFS. In a NAS environment, ontap controls the file system. A storage area network, or SAN, provides block-level access to data, typically in units of 512 bytes. SAN solutions can use the Internet's Small Computer System Interface, or iSCSI, Fiber Channel over Ethernet, or FCOE, and Fiber Channel, or FC protocols. In a SAN environment, the host operating system controls the file system. A storage system that includes both NAS and SAN protocols is called a unified storage system. This course focuses on block-level access that uses the SAN protocols. This section introduces storage area networking. In an application server environment, locally attached disks can be used to store application data.
Jalan-jalan lang.
Locally attached disks,
Mandi dulu sana.
called direct attached storage, or DAS, are separately managed resources. In an environment with more than one application server, each server storage resource also needs to be managed separately. A SAN provides access to a logical unit called a line, which represents a SCSI-attached disk. The host operating system partitions, formats, writes to, and reads from the line, as from any other locally attached disk. The advantages of using SAN storage include support for clustered hosts, when shared disks are required, and centrally managed resources. In this example, if a SAN was not used, the administrator would need to manage separate resources for each application server and host cluster. In addition to centrally managed resources, SAN enables centrally managed data protection using ontap snapshot copy technology. In NetApp storage systems that use ontap, hosts communicate with runs across an FC switched fabric network that uses the FC protocol, an Ethernet network that uses the iSCSI protocol, or a converged Ethernet network that uses either the FCOE protocol or the iSCSI protocol. In all cases, the transport portals carry encapsulated SCSI commands as the data transport mechanism. SCSI provides low-level block access to data, typically in 512-byte blocks. Low-level block access is highly efficient and requires less overhead than NAS or file-level access. SCSI has a high level of resiliency that makes SCSI a perfect enterprise-level protocol. A client-server service delivery model describes the relationships between SCSI devices. A relationship between two SCSI devices is called a nexus. The client or SCSI initiator sends a command, and the server or SCSI target returns a response. The initiator uses SCSI commands to request a read from a LUN or write to a LUN. iSCSI does not use the complete SCSI standard. Rather, iSCSI uses TCP/IP as a transport mechanism, but retains the SCSI architecture. SCSI commands are simple data structures that describe an initiator's request. Each command contains an operation code or opcode that describes the command. For example, read or write. Following the command are the arguments and options that define the specifics of the command. For example, where to read from and how much to read. All SCSI commands are defined in the SCSI 3 specifications. This section introduces SAN terminology. SCSI transmits data between a host and peripheral devices through adapters that use SCSI commands to communicate. Traditionally, storage is attached to a local system. In an IP SAN, the data traditionally travels via Ethernet ports. These ports can be on devices or on network interface cards or NICs. NICs are also called network adapters and LAN adapters. In an FC SAN, data travels via FC ports. These ports can be on devices or on FC host bus adapters or HBAs. Traditional networking has evolved into something called converged networking, which enables multiple protocols for one network. A converged network adapter, or CNA, combines the functionality of a NIC and an FC HBA. A CNA is sometimes called a converged network interface controller. A CNA enables the use of the iSCSI, FC, and NAS protocols over a single Ethernet port. In a SAN environment, instead of using local disks for data, the host uses LUNs on the storage target to logically represent a local disk. Such a configuration increases reliability and enables the feature-rich functionality of ontap. A LUN is a logical representation of an attached SCSI disk. SAN is often called block-based storage because hosts write to logical blocks instead of to attached SCSI disks. Logical blocks are 512 bytes per sector. In ontap systems, do not confuse logical blocks with 4 kilobyte waffle or write anywhere file layout blocks. Waffle blocks are physical blocks. ontap stores 8 512 byte logical blocks in one 4096 byte physical block. Each storage virtual machine, or SVM, with FlexVol volumes represents a SCSI target. In a SAN environment, volumes are used as containers for LUNs. The host, or initiator, is then given access to the LUN to store and retrieve data. Although FlexVol volumes can contain one or more LUNs should never be created in the SVM root volume. A data logical interface, or LIF, that's assigned with SAN protocol access is often called a SAN LIF. SAN LIFs are created so that a host can access LUNs from a specific SVM. SAN LIFs are single protocol and can be assigned either the FC or iSCSI protocol. When a LIF is assigned the FC protocol, addressing is automatically assigned. When a LIF is assigned the iSCSI protocol, you can assign an address manually or automatically. Although SAN data LIFs do not fail over, they can be migrated. However, there are restrictions on how SAN LIFs are migrated. See the SAN administration guide for more information about migrating SAN LIFs. In an IP SAN, a unique node name, the iSCSI qualified name, or IQN, describes the iSCSI software or hardware initiator on the host and each SVM. Details about IQN naming conventions are explored in greater detail later in this course. The term portal describes each iSCSI interface. Ethernet ports on the host are configured as network portals, and iSCSI lifts on the SVM are configured as target portals.
What?
After a physical connection is made between an iSCSI
Okay.
initiator and a target,
Ada,
you need
lupa.
to create a
Di
session
entry.
to enable communication.
Halo.
In FC-SAN, each FCHBA on the host and each SVM is assigned a unique worldwide node name or WWNN. Each FCHBA port and each FC lift is assigned a unique worldwide port name or WWPN. Details about WWNN and WWPN naming conventions are explored in greater detail later in this course. Target adapters and ports are similar to initiator adapter ports. Recall that an IP-SAN usually uses Ethernet ports for communication, and an FC-SAN uses FC ports. These ports are located on board or are available by installing adapters. For FAS and all-flash FAS systems, Ethernet ports support iSCSI, FC ports support FC, and Unified Target Adapter or UTA ports support iSCSI and FCOE. UTA2 ports can be configured as either FC ports or Ethernet ports. When a UTA2 port is configured with the FC personality or FC mode, only the FC protocol is supported. When a UTA2 port is configured with the CNA personality or CNA mode, iSCSI and FCOE protocols are supported. For some conditions, hosts can be directly attached to storage controllers. Such a configuration is supported only when the iSCSI protocol is used. Even then, you should avoid the configuration, which lacks resiliency and scalability. Hosts usually communicate with the storage controller through a network or fabric. You should use redundant networks or fabrics for resiliency and scalability. This section introduces the implementation of SAN. To implement an ONTAP SAN, first license or verify the FC or iSCSI protocol. To enable block access, assign the FC or iSCSI protocol to your SVM and create the appropriate lifts for that SVM. Protocols will be covered in modules 2 and 3. As part of configuring your SAN environment, you must create a LUN, create an initiator group or I group, and map the LUN to the I group. LUN mapping is the term that's used when a host or initiator is permitted to access the LUN to store and retrieve data. Creating LUNs, I groups, and LUN mapping will be covered in Module 4. After mapping the LUN from the host, discover the LUN that the storage system is presenting.
Ada.
As you learned, the LUN is a logical representation of a SCSI disk. You prepare the LUN like any standard disk by formatting the LUN from the host operating system. Preparing disks and other host considerations will be covered in modules 4 and 5. It's important to verify that the components and software on the host are compatible with the version of ONTAP that's running on your storage system. The Interoperability Matrix tool, or IMT, is a helpful web-based utility. The user-friendly IMT interface helps you search for NetApp product configurations that use third-party products and components that meet the standards and requirements that NetApp specifies. Host Utilities is a set of software programs and documentation that enables you to connect host computers to LUNs on NetApp storage systems. You can download Host Utilities from the NetApp support site of the operating system that's running on your host. The available host utilities features differ for each operating system. Windows Unified Host Utilities, for example, includes an installation program that sets required parameters on the host computer and on certain HBAs. For example, parameters include setting timeout values to enable proper failover. The package also includes documentation that describes how to install the host utilities and troubleshoot problems. There might also be diagnostic programs for troubleshooting problems with hosts that connect to the storage system. Match each term with the appropriate function.
Cocokannya jangan rukun. Jangan rukun mentok. Yang jemput siapa? Yang jemput nanti siapa? Yang jemput nanti siapa?
Ada ayah.
Oh iya. Rumahnya di mana emang?
Rumahnya di Jalan Puskesmas.
Oh, dekat Jalan Rukun aja.
Iya.
Dia kasih tahu Jalan Rukun. Apa minta di SMS?
Tapi tadi minta di SMS.
Yang ini ya nomornya ya?
Iya, 08.
Which market?
Ya, terus cakra. Oh, udah masuk jalan kebun ya? Oh, mentok ada tukang sayur. Iya, ada tulisan kirasa. Iya itu di dalamnya. Masuknya lagi di dalam. Di pasar sebelah kanan yang warna itu. Iya. Benar. Itu nggak ada tuh.
Ih, itu lihat hujan lagi keberutnya jangan panas dulu. Tuh lihat keberutnya. Pagi aja udah mati ya. Pagi aja udah mati. Juga dalam hati membangkit sih orang kayaknya nggak mau ditinggal ya. Oh, orang ada kecil aku lagi di sini kamu. Ayo Neng, Aida. Ya Allah Robi itu anak ya. Lagi lama emang kemana? Raida, cepetan dong deh, kamu mah dilap aja nggak mandi dan dipempes. Banget lagi. dilein deh. Udah, habis mandi nggak boleh giginya kotor ini. Saya kena cabai, Yuna. Jangan mau, Raina belum mandi di bawa pobi, bawa cek, entah jatuh, izin becek. Sama papa. Dilap dulu makanya nggak harus dilap mah. Kamu mana mau tinggalnya aja basah tuh kotor becek. Udahnya kotor. Ih, dibilangin ya. Jangan tidak. Tidak. Lap dulu makanya, diganti dulu kampusnya. Dari tadi udah diikutin aja.
Jadi deket ya, buat belakang. Makanya nafsu orang. Itu judulnya.
Nanti kalau ada nggak mau mandi, Mbak yang mandi ya. Kita habis Mbak mandi ke rumah. Baiklah. Dengar nggak dibilangin? Ya, iya. Mbak mau mandi dulu. Ntar habis Mbak mandi baru makan ya. Jangan makan apa-apa dulu.
Apa juga mau makan? Ambil dong.
Ya, sekarang aku mandi dulu. Jangan aja kalau habis sayur di kompor, Kak. Ada berapa kalau mau makan?
Yang gini dong. Kamu. Om udah makan belum? Mandi dulu biar gak nyemukin. Biar bisa tolak biar gak nyemukin. Takut. Iya. Mereka berani. Yang mereka. Iya. Ini seru banget. Kamu harus dulu. Susah banget sih. Kamu yang baca itu loh. Lalu 6. Bentar. Ya. Ntar apa lagi ini? Ntar, dikit lagi. Sini. Ya juga nih, ntar dulu. Kalau bilang ntar dulu. Ayo. Oh. Ini juga ya, ini juga loh.
Itu kan malah makan cuma ya. Kan udah dibilang nih, jangan makan apa-apa dulu dulu kita lagi makannya. Terus kalau nggak dilap dulu cepat ya. Yuk dilap dulu. Dilap dulu sebentar, ganti dulu popoknya. Ntar kalau misalkan masih susah, Mbak tinggalin. Biarin aja di rumah sendiri. Enggak mandi. Pintu. Pagi-paginya ya, pagi ya. Ayo cekok dulu.
Buat mau di sini juga. Mau. 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 Sintuknya. Papa nggak mau pergi, papa maunya pantat aja. Yes. Jadi monster, jadi zombie, datar, jadi vampir, jadi Dracula, jadi jadi lagi.
Biarin aja dibuang-buang, gak mau pakai ini lagi, biarin.
Ini yang dibuang. Siapa yang pakai? Siapa? Hei, tuh kan dibuang lagi. Mau cinta kan? Cinta.
Biarin aja. Bu. Katanya aku nggak mau minum obat. Kalau nggak mau minum obat pakai pik biar cepat sembuh. Merem matanya merem. Udah cepetan sini baju. Tolong bajuin dulu, nggak mau deh. Ya udah dibaju sama papa, mbak nggak jelasin mam.
Udah pakai pampers belum? Cepat, kalau nggak papa cintuk nih. Nah. Ayo cepetan. Ayo angkat keburu makan kecoa lo, datangin kodok tuh. Ini ayo, angkat kodok nyamperin nih. Kan? Itu kenapa tuh ini? Ini makanya cepet. Nggak mau nanti ini datangin kodok nih. Nggak mau. Angkatnya. Kodok.
Ada momom di mana? Sambil nempel.
Lu sakit. Yuk sini, cintuk dulu. Siang, cintuk. Ketemu ya. Udah biarin. Biarin. Enggak, kamu mah teriak-teriak mulu udah kayak hampir. Au. Au. Au, au. Au. Aduh, kok gitu? Kan mam dulu sana.
Ada begini aja.
Mam dulu, mam. Aja. Mam dulu ke sana.